Hi guys, welcome to this "You Build It, You Run It" video. Well, it's an iconic phrase, so we'll check it out in a minute. So first of all, I wanted to introduce you like in a what happened like 15 years ago. So take for example that it's 3 a.m. on a Sunday and somehow your production application is down, so your consumers can't access their account, for example. So at that time, the operational team is trying to fix the problem for something that they didn't build, right? While meanwhile, developers who wrote the code of that application were asleep, I don't know, doing or on a party, doing whatever they were at. So that was what was happening like 15 years ago. That was the reality for decades. So the problem was that we have a fundamental flaw in the organizational structure. We have basically two separated worlds. Developers who build software, wrote the code, and test it, and the operation teams who run the in production. So between them, there was this invisible wall. Somehow you could picture this as developers writing their code, doing their tests on their laptops, and then when they finished, they threw it over the wall to the operation managers, and when their job was done, ship it and forget it. They didn't want to know anything else. If there was a problem, they would say, oh, it ran on my laptop, so now it's your problem, operational team. So somehow operations teams had to engage with this application they didn't write and try to solve problems they didn't create. So they were trying to fix, trying to guess, trying to understand how it was built, and so on. So the incentives were totally misaligned because developers were measured in how to build fast, right, and ship new features very quickly. From the other side, the operational teams were measured on system stability, right, the uptime percentage, and so on. So they had different goals and they were in conflict. So DevOps, or sorry, dev teams were wanted to move fast, while operations wanted to move more carefully. So the result, well, they they engaged, they had conflict, they blame each other, and so on. So the most problem was we had unhappy customers, right? So this phrase, "you build it, you run it," was coined by Werner Vogels, the Amazon CTO, on 2006. He introduced this radical idea that would transform how we build software. Because although it's very simple, you build it, you run it, it was revolutionary at that time. Now, with this new concept, the team that writes the code owns the codes in production forever. No hands off between teams, no throwing things off the wall. If your code breaks at 3 a.m., you need to fix it. At first, well, developers were terrified because they didn't know how to run correctly on production systems. So it was at the beginning, they need to understand what were the ping points, making stress tests, I know, improving the monitoring, the logging, and debugging, etc. So it came to a time where there was some kind of transformation where developers started to get to know what were the production problems that were different of the problems they had on their laptops. So they started to write better code because although no one told them to write better code, it was obvious that they didn't want it to be disturbed at 3 a.m. They didn't want to manage problems. So they try to build better software so they didn't have pain on other on their out of office schedule, right? So after this decision came out, they worked more on the debugging, on error handling, and it became more crucial, this kind of monitoring and observability. So developers started to asking themselves, well, how will this fail instead of how will this work? So their mind switch off to somehow trying to prevent failure. Um, Let me show you. Well, this model, I just wanted to say that has been proven, and it has been used massively by major leading companies from Netflix or Amazon to Shopify. So right now, all these companies, the engineers who build and deploy the code, they are the owners of this of their applications. So between the teams that build the software, they make the shifts and the rotation. So someone of the team is active or on guard when they switch for a week. So one week, one people of the team is active on guard, and they switch every week, and so on. So that's a very summarized version. So basically, this concept, you build it, you run it, restructure how teams were configured. At the beginning, as I said, we have development teams and we have operational teams. I then were separated. Right now, the most common structured team approach is that within each development team there is a DevOps or someone with operational capabilities, and that's one typical approach of small companies. But also it's very common that when you have multiple development cells, there is a transversal team, DevOps team, that it's always training and giving advice and insights to each of the teams on how to build the software in order them to monitoring, to observe, to get critical errors, and so on. Let me show you a quick presentation I got here. Here it's a quick overview about how was this handled time ago. Let me open this. Here it is. Okay, can I switch? There it is. Well, typically, well, I don't want to get into much detail, but well, it's also not very clear, the picture, because I just wanted to show that there was a clear, in the pipeline, there's a clear division between all the development flow before the deployment, and after deployment, it was somehow on the operational teams, right? So, well, this means they were in conflict every time. It started, development started to use a centralized logging system like Logstash, for example. So all application logging went to a central repository, so they could query from some information to all services in a single point of in a single central point, right? And they start building software for monitoring. This is Grafana dashboard, typically, which is used a lot for monitoring containers, right? So at some point, when software development improved, they had more, bugs were more common at the software level rather than the infrastructure level. So that's the most common. So that's why it's much better to developers to get ownership of their code. So well, these are some famous phrases. This is from Black Scrivener from Netflix. So it's very straightforward. When things are broken, we want people with the back context try to fix things, and it's a development team, right? It's obvious. Also Airbnb, it says when having separated operations teams, it says they create division. It didn't scale. It puts one's responsibility for fixing an issue on the wrong team, because it's not correct that operational team fixes development issues, and so on. So, well, this entire concept brings down to the ownership stuff. So developers own the product for its entire lifetime, from all the from everywhere, from building to running, right? So ownership, it's a key concept. Well, this phrase, it's from Spider-Man: with great powers comes great responsibility. So now developers knows what they up to. So by owning the application, they stand out for creating more reliable software, and they become expert in supporting their existing work, right? Um, well, I just wanted to do a quick mention about guard or being on call, where each engineer is on a rotation schedule. Well, just wanted to say that they are the first to they are the first one to arrive when there is an issue, an incident in production. So they try to typically, or what we need to do is to move backwards, do a rollback. We shouldn't try to investigate what is the root cause of the incident. It's not recommended. We should try to roll back to a previous version, for example. And I'll stand out because this we'll see in some areas. And I think that I will prevent this from commenting because we will see it in the next course. Okay, that's it. Thank you. Bye bye.